Good evening, ladies and gentlemen. I'm really sorry. I apologize for the delay because we were experiencing some technical issues. And yeah, I was talking that's the main reason of the presentation as well. That these kind of constraints or bottlenecks which we are experiencing in our day-to-day communication, which is improving every day, and we won't be able to face it when we are talking about the running bits and bytes from 5G and LEO HTS Mega-Constellations. Yeah, LEO stands for low Earth orbit. HTS stands for high throughput satellites. So we already have 30 minutes delay, so I will try to be as precise as possible, and I hope most of us have an understanding of how the mobile communication works, and we have been witnessing the fourth industrial revolution, and it is totally based on technology. That being said, I am unable to again, and there are some technical issues again I'm facing. I am unable to share my screen, but still, bear with me, and I will try to explain what I was about to talk. And the topic is running bits and bytes, 5G and LEO HTS mega constellations. So why we are moving in that direction? The reason, if you analyze that, for example, we talk about the video streaming quality. We are talking about 4K at the moment, and the resolution is increasing to 8K, 12K, and then we are going to have some 3D channels as well. Yeah, 3D TV channels with 3D live broadcast specifically for sports related events, and soon it will become a reality, and almost really we will be witnessing such things in the near future. And for the, you can say, the growth in resolution, or the increase in the resolution, and that requires good infrastructure of communication for streaming, for storage, for memory, and for other stuff. And I'm talking only about video streaming like Netflix, or we have the streaming channel. I'm not talking about the broadcast channels. I'm not talking about the data we are producing from other, like this webinar which we are conducting on Facebook. I'm not talking about YouTube. I'm not talking about other stuff. So that's why if we consider so many things that are going on, and every other day there are new applications coming in and that have millions of subscribers. The cell phone which we used to for mobility, and we only used to make phone calls and send text messages, has become a handheld computer with so many applications, so much you can say computing power and memory, and all these applications require cloud storage and constant connectivity through the storage and to the service provider. So every person is generating a huge amount of data, and that data is increasing every day. And previously, as I said, that we used to only have one cell phone that was for emergency calls or keeping in touch with your loved ones. Now we are talking about smartphones. We have smart devices, and every person is on average having 4 to 5 devices attached to that person. We are talking about wearable devices. We are talking about smart household devices, Internet of Things, and these technology is growing every day. So to accommodate that, to accommodate the data we are generating, to accommodate the data traffic, that data has to be transmitted from one point to another, or from multiple points, or from one point to multiple points. The communication infrastructure has to be strong enough, and has to be smooth enough to avoid any kind of bottlenecks which we can have at the moment. So currently, we might be satisfied with our networks, or our, you can say, usage of our network and how much data we are communicating. But when we're talking about the future, these things are going to be changed. So that's why the fifth generation of mobile communication, which we in short call the 5G, is coming, and it is going to replace the previous generations. And this is not only a communication infrastructure, but it's a complete system because it has so many use cases and it is addressing so many issues that we normal person cannot identify at the moment. Let's say that the fourth generation of mobile communication, uh, it was we are talking about in Mbps, megabits per second, but fifth generation mobile communication, the 5G, commonly known as 5G NR. NR means new radio because it will be using a lot of new frequencies. And it will be going up till 10 Gbps. The latency, which we are having about 40 millisecond in the fourth generation of mobile communication in 4G, it is going to reduce to 1 millisecond, but that will be only for the mission critical like autonomously driven vehicles. Again, another use case, another big improvement in technology. And then again for search and rescue and other mission critical applications. So the latency is going to reduce a lot. We are talking about huge data rates and enhanced mobile broadband, the use cases, and massive machine type communication. 4G had the capacity to accommodate 100,000 devices per square kilometer, and 5G will have the capacity to accommodate 1 million devices per square kilometer. So what is 5G? 5G is the fifth generation and the standards are made by 3GPP, the third generation partnership project. And they make the standards. Third generation partnership project is comprised of academia, engineers, scientists, uh, equipment manufacturers like the vendors and mobile operators. And they basically work really, really hard to formulate these standards. And these standards are basically made in response to the requirements from International Telecommunication Union, ITU. ITU is the body of United Nations and it regulates spectrum and satellite orbits and things related to telecommunication for its member countries. And they basically make these requirements and submit it to 3GPP to make the standards for the next generation mobile communication. And currently, 3GPP is the only organization which is making the standards for the 5G mobile communication. Previously, up till 4G, there were multiple competitive standards, and there were different organizations which were making those standards. But now, for 5G, we only have one standard, so there will not be any issues for interoperability or using of your handset in specific countries will not be a problem. So, what 5G NR? This is the new radio, and why new radio? Because if you're talking about radio frequency electromagnetic spectrum, it's a huge spectrum, and it comprises of all the electromagnetic energy we can have, we can observe, and we can monitor in the universe. Uh, Visible light is one of that. Is a small portion of that. Our audible frequency is a small portion of that, and we have gamma rays, we have X-rays, we have ultraviolet rays. The radio frequency spectrum comprises only from 3 kilohertz to 300 gigahertz, and we normally perform communications in that spectrum. And for that, we have been using a lot of, most of the people can understand that we have been using frequencies, and they know that, for example, we are talking about a Wi-Fi router, we know that it's operating about 2.4 gigahertz or 2.5 gigahertz or 5 gigahertz. And 4G, up till 4G, we were talking about something up till 3.6 gigahertz. But now, 5G new radio, it will be using a lot of new frequencies. Very, very high frequency range will be used for that. Because again, as I said, that we are increasing the data that we are generating and we are consuming. is increasing, and to accommodate that transmission of that data, we have to use a lot of new frequencies. And we are now listening to the word millimeter wave, and that will be from 24 gigahertz up. If you're talking about Federal Communication Commission, the regulatory authority in the United States, they have given frequencies up to 95 gigahertz for operation for 5G communication. And one thing that we must understand, the higher the frequency, the lower the distance of its coverage. So it means that 5G will be having more base stations as compared to 4G. So we are talking about, but that will be the case in highly populated or urban areas. When we're talking about suburban areas and rural areas, they will be using the previously used frequencies for the previous generations of mobile communication. So that, and they also have a very beam width and port to accommodate that. They will be using massive MIMO, multiple input, multiple output array antennas will be used. It will not be like your typical cellular tower which we see in our suburbs or at the top of the buildings, and if we go to the high-rise building areas or the downtown. So the array antennas will be introduced, and they will be just like the Wi-Fi routers which we have in the buildings, and we will be having 5G communication access to those through millimeter waves, and every user terminal will be having a dedicated beam beamforming will be used to have a dedicated connectivity to the base station. So we are talking about enhanced mobile broadband. We are talking about URLLC, ultra reliable low latency communication. That is for mission critical. We will be having 1 millisecond of latency, and then again we have massive machine type communication. That is terminology that is being used for Internet of Things in 5G, IoT, which we normally use for the devices that will be communicating with the internet. So in 5G we call them machine type communication, which before the use of terminology of IoT, it was used MTC, machine type communication, or M2M. So a million devices per square kilometer. So this is going to be a huge change in our communication infrastructure, but it will take time. And the 5G will be rolled out in two stages. First one will be the 5G non-standalone, and in that case, there will be 5G base stations, and they will be communicating with the. They will be using the 4G core or EPC, evolved packet core. So the base stations will be will be based on the 5G technology, and the core network that will be used will be from the 4G or EPC. Then it will be followed by 5G standalone. In that case, the core network will also be replaced by the 5G core network, and we will have complete 5G rollout. And that will be using millimeter waves and massive MIMO and MMTC. Those things will be. So it's a time consuming process, and it will take time until we completely experience the true benefits of 5G. So why the second part of my presentation, which I was talking about LEO HTS, lower Earth orbit high throughput satellites communication mega constellations. That is again, satellite communication is there for more than half a century, and it was conceived by Sir Arthur C. Clarke. He was a science fiction writer, and most of the people know him by his tremendous work. You people will be seeing monoliths appearing at different locations, and people are referring it to the sci-fi movie 2001: A Space Odyssey. Yeah, the writer of that movie, Sir Arthur C. Clarke, he basically gave the idea of satellite communication, that three very well calculated distance satellites in an orbit can communicate throughout the whole globe. And based on it was published in 1945, and based on that, the satellite communication was born. And satellite communication currently we are using geostationary satellite for all of our satellite communication needs, just like the broadcast, live TV broadcasting we see from, if we look at your any live transmission you see live via satellite, or any breaking news or any sports event. So those satellites are at an altitude of 37,000 kilometers, and they cover a huge portion of the globe, depending upon the frequency. Like if you're talking about C-band, so one third of the globe is covered through the C-band communication from 37,000 kilometer altitude. Those satellites, they have been serving us for half a century, and they provide us global coverage. So there are almost 3 billion devices, almost half the population of, 3 billion people, almost half the population of the Earth, that is not served. That are not connected. They are not on the grid of communication. The reason behind that, most of our population or the developed areas, they have mobile communication infrastructure. But if we go into the deserts or mountain ranges or the oceans or the isolated islands, they are not connected, because for the communication, we need fiber cable or microwave transmission to communicate, to get those communities connected to the core network, or the cloud, what we call it now, or the PSTN we used to call a couple of decades ago. So those satellites have been serving those communities, but it was a very expensive medium, because satellite communication bandwidth, again, the operators and the infrastructure required to for at the ground station was very expensive, and we need to have very highly skilled people to install those infrastructure, like the dish antennas, which we see at different top of different buildings. Or the capex and opex of maintaining those communication links was very high. This gives the idea to our tech giants like Elon Musk or Jeff Bezos or Richard Branson to provide global communication with global footprint and very low latency. And the one thing I missed about the geostationary satellite communication was the latency. And for a round trip from, let's say, if I'm communicating from this location in Brisbane to any location near the world, it was about 530 milliseconds. So compare it with 5G, we are talking about 1 millisecond, and satellite communication, we are talking about 530 milliseconds. Most of the Industry 4.0 applications or technologies based on that cannot afford that much delay. So to address the latency and to address the capex and opex of the expensive satellite communication, they came up with low Earth orbit, high throughput satellites, which are smaller in size, which are very closer to Earth. The low Earth orbit is up to 2,000 kilometer altitude. And Elon Musk came up with his constellation named Starlink, SpaceX Starlink. And he introduced another orbit like VLEO, very low Earth orbit, and it is about 300 kilometers. So, but when we're talking about low Earth orbit, so closer to the Earth, the closer to the Earth we get, the coverage footprint gets smaller. So, meaning that one geostationary satellite was covering an area, there needs to be a lot of low Earth orbit satellite to cover the same area. And again, the geostationary satellites are around about 37,000 kilometers. They remain stationary at their orbital position, but these satellites cannot remain because they are very close to Earth because of the gravity. They have to keep moving at a very, very high speed, around 9 kilometers per second, the velocity that these satellites will be having. And the number of satellites will also increase, but we are having low latency, and we are having the global coverage. So the number of satellites is increasing, and that might surprise you that soon we will be having 100,000 satellites orbiting the Earth in low Earth orbit. SpaceX Starlink from Elon Musk will be coming up with 42,000 satellites. OneWeb will be coming through 48,000 satellites, and Jeff Bezos, Amazon, they have introduced Project Kuiper that will be coming up with almost 3,300 satellites. So these satellites so many satellites from Starlink have already been launched, and they are having testings, and they are talking about latency of around 20 millisecond to 40 millisecond. Yes, that's at par with 4G, and data rate varying from 50 Mbps to 150 Mbps. So that's a huge improvement. And to add to that, the terminal is very small. The user terminal is very small, plug and play with the Ethernet interface. So you can put it, mount it on your car or at the roof of your home, and you can connect your Wi-Fi modem with that. And the one more thing that is that the terminal cost is around $600, and the monthly charges are you can say at the moment they are talking about $100 per month. So if we compare it with the geostationary satellite communication, it is you can say negligible. So this is the technology which we are talking about. The bandwidth is much more improved as compared to geostationary satellites, and these are going to be the game changer, and they will be used for everyone everywhere will be connected, and there will be a lot of opportunities with arrival of these two technologies in parallel, the UHTS Mega-Constellations and 5G mobile communication. There will be a lot of opportunities for job creations and further research and development, because they have already started. The 3GPP will start working on 6G standards from next year. Yes, they are working on 6G now. 5G is not rolled out yet, and they already have started working for 6G, and they will be having latency in microseconds, data rate in terabytes per second, and they already have started working onto that, but it will be by 2030 when we will see the technology being deployed. So there are a lot of opportunities, there are a lot of growth, there is a lot of growth, there are a lot of possibilities for job seekers, for future students, for entrepreneurs. You can have a lot of opportunities in agriculture, in earth observation, in providing. Just imagine that 3 billion people who are not on the communication grid of the world will be there on the grid. So why tech giants are investing into that? Just for fun, let's say Jeff Bezos is investing in satellites, and he's coming up with so many satellites. So people in isolated communities will be able to order from Amazon, or they can have Amazon Prime subscription, or he can send shipment to them. So logistics, applications, cell phone sale, so many verticals are there that if we look on to those things, and the possibilities are limitless, and it's just the beginning of new technologies, and the next generations of these constellations, satellite constellations, the next generation of mobile communication will be more surprising than these one. We are still surprised with this one, but yeah, the next one will be more surprising. So we have to be prepared, and we have to look for the right opportunity for our personal growth or the growth of our organization. And one thing I would like to suggest that keep learning. What we learned a couple of decades ago, what we learned half a century ago, what we learned last year, what we learned last week is outdated. Technology is evolving every day, every minute. So we have to keep ourselves up to date, and we have to keep increasing our knowledge base if we want to be successful. That is the key. And I hope it was I contributed something to your knowledge, and I was able to convey the things without the presentation. Again, I am really sorry I was not able to share the screen or share my presentation with you guys. I really apologize again. There were some technical issues, and these issues will be addressed when 5G is here, or if I get a terminal from SpaceX Starlink, I will be in much better position to talk to you again. So if you guys have any questions or if you guys have any suggestions, I am here. You can ask me. Anyways, if you have any questions, I am available in Research Collaborators. And Dr. Hasnan, thank you very much for inviting me and giving me these opportunities. And I think this video will be available on the group and the Research Collaborators YouTube channel as well. You can ask me the questions there as well, and you can send me a message if you want to know anything or if you want to suggest me anything. I'm uh, okay. We have a question. This is Kuratul and Zahra. Yes, I'm listening. How can I help? Yeah, one more thing I want to add, because of this COVID-19 going on, and there was a lot of conspiracy theories going on that 5G is the reason behind the spread of this virus. And believe me, there is no correlation between these two. The radio frequencies, as I mentioned in the beginning of my talk, 3 kilohertz to 300 gigahertz, are non-ionizing. It means they are not creating any ions. They only can produce heat, and if we are talking about change of any molecular structure, it is not possible through radio frequencies. They only produce heat, just like the microwave ovens we use. They use the radio frequencies up to 2.4, 2.5 gigahertz, and they heat our food. And if you are getting alarmed with that, it is using about 1000 watt transmitting power, and it's in a very closed chamber, few liters. And the base stations of the cell phones we are talking about, and the transmit power they're using, it's in milliwatts and up till 1 watt. So yeah, obviously it's a man-made thing, and it is getting into our system. They are at some point there will be a lot of personally I consider it a pollution, but it's not. It has nothing to do with the COVID-19 or any other stuff. It's if it has to be, then we are much more. The sunlight. The sunlight is much more harmful if talking about ultraviolet rays or gamma rays or the X-rays. They produce iron, or they can change the chemical properties of any structure. Yes, Kuratun and Zaha, new radio. New radio means new radio frequencies. Up till now, we have been using radio frequencies for all the generations of mobile communication up till 3.6 gigahertz. For new radio, we are using a lot of new frequencies for 5G. And up till 300 gigahertz, but for now we will be using up till 95 gigahertz. So there are a lot of different allocations. If you can, I will share it on the group. Unfortunately, I'm really sorry. I was not able to share the screen. I was not able to show you all the things that I had in my presentation. So I had to talk it out. And yeah, new radio means new radio frequencies, which will be used by the 5G. And then we have Sayyid Rashid Ali. Yes, future generation wireless communication tower might be installed on a satellite base station. Yeah, we have been using it with the traditional geostationary satellite as well in the remote communities. If we talk about, let's say, if I'm talking Australia, there are some remote isolated communities. We cannot afford laying a fiber cable to those communities, or we're talking about the islands. Geostationary satellite were used, and the dish antennas were installed, and along with them were the base station. It was known as cellular backhaul over satellite medium, and it has been used. It has been, and it will be used for 5G as well. And the new satellite constellation will be used for that as well. And it will. We were very comfortable up till 2G or 3G. But 4G onwards, the traditional geostationary satellite, as I said, the latency is very high, up till 530 milliseconds. So most of the applications sync out, they do not synchronize. And to address that, the LEO HTS Mega-Constellation will be there to help us. So if there are any other questions, I will try to help you. If not, at the moment, then you guys can always comment in the group, and I will be there to help you guys, and you can send me the message, or I will share my contact details in the post. You guys can connect me. So these two are separately things, because 5G is mobile communication, and the ground station, geostation satellites, they have been used together. And if let's say we have a base station at a isolated community, and it is serving those people with mobile communication, let's say 2G or 3G, and we are using geostationary satellite for that. Then we have to install a geostationary satellite antenna, which is commonly known, which we normally know as the VSAT, very small aperture terminal, for communicating with the geostationary satellite. And at the MSC or BSC or the core end, we have bigger antennas, because it is transmitting and receiving from a lot of remote stations. So the cost of that antenna, if we are talking about the remote antenna, we can work on the 1.8 meter or 2.4 meter, or if it's a cluster of different sites, then 3.7 meter, 4.8 meter. But if you're talking about the hub end, then we are talking about at least 4.5 meter, and it can go up to 9 meter, 13 meter. So the cost of that antenna is already very high. Even if you get it used in the market, installation, it requires very special skill sets for installation. And before you start your communication, you need to have a lot of link budgeting done before you start communication. You have to perform a lot of tests with the satellite operator, and you have to have 24/7 availability of team at remote, and you can say the hub end. But for talking about LEO-HTS Mega-Constellation, it's a handheld device, and it's talking about 150 Mbps and 20 millisecond of latency. So 150 Mbps is good enough for 4G, for a 4G base station. And for 5G, if again it's an isolated community or it's a remote community. As I said, there's a 5G massive MIMO or high frequencies array antennas, or they will be used in very densely populated areas inside the buildings. And it's an isolated community, so the same standards that are applicable for a rural area will be applicable over there. And the cost of the capex of 5G will be there. You cannot change the capex of 5G. It has to be the capex of but the capex of satellite communication or the satellite media, which we were previously using for isolated communities, will reduce a lot. I'm really sorry again. I'm not able to share the screen, and there were a lot of things I had to show. Okay, I will share the details in the group. You can learn from there. Just to let you know that I'm myself an engineer and have worked as a satellite communication engineer, and I have been working on this. This is my expertise that I have been providing satellite media to 2G and 3G remote sites in Pakistan, and now I'm back in research after a long time working in the industry. I am back in research. My previous research was based on 5G mobile communication radiations, which I was talking about, that these radiations are not as harmful as they have been predicted in the news or in the conspiracy theories lately. And let's say currently I'm working on these LEO HTS mega-constellations. Latency comparison of 5G and lower orbit satellites, LEO HTS mega-constellations, is if you're talking about Industry 4.0, then 5G will be having 1 millisecond of latency, but for normal usage will be 10 millisecond. 1 millisecond will be only for mission critical applications like self-driving vehicle or search and rescue operations. They will be having 1 millisecond of latency. Normally we will be having 10 millisecond, but LEO HTS mega constellation, currently, we only have test results for SpaceX Starlink, and they are going to deploy 42,000 satellites, but they are not deployed at the moment. So we are having around 1,000 satellites in the orbit. To have a complete analysis of their performance, the whole mega constellation has to be in the orbit. But for the result at the moment, the latency is varying between 20 millisecond and 40 millisecond, and it is surprisingly really good because it is at par with it is better than you can say 4G. So if you're talking about Industry 4.0 application, these mega constellation or these satellites, basically they are going to be used for backhaul or you can say backhaul communication, or these satellites will not be communicating directly at the moment with our handheld devices. So it's not like that we are having 5G base station flying at a lower Earth orbit, and it is again it is a big challenge technologically, that how our handheld devices with our mobility and with the satellite moving at 9 kilometers per second, and we are having handovers every few milliseconds. It's maybe down the line, and the second or third generation of these mega constellation, we will have applications that we are able to communicate them directly with our handheld devices. So they are using a terminal, just like we have fiber at our home, and we are not communicating directly with the fiber. We have a Wi-Fi modem, and we communicate through the Wi-Fi. So it is basically again an access point. The terminals are there, and they will be basically distributing locally to all the applications we have alongside that terminal. So if there is any other question. Okay, thank you again, research collaborators, and especially Dr. Saitasna and Shirazi for inviting me and giving me an opportunity to discuss with you guys what the technologies are coming. And keep in touch. I will be there in the group. If you have any further questions, we will discuss it over there. And I will try to share the findings or some information about these things in the group. Thank you very much, guys. Stay safe and enjoy the rest of your weekend. And stay blessed. Bye bye.